Now let's look at question number 2a. State Faraday's laws of electromagnetic induction. Now, there are two Faraday's laws. The first one states that whenever magnetic flux linked with a coil changes, an EMF is induced in the coil. Whereas the second law quantifies the value of this EMF induced, and it states that the EMF induced is directly proportional to rate of change of magnetic flux. Question 2b. Complete the following diagram and label the principal focus and the second focus, that is F1 and F2. Have a look at this diagram. There's a concave lens shown in the question out here, and there's a ray emergent after striking the lens from this side parallel to the principal axis. Now, we have to draw the incident ray approaching the lens. So, in that case, first of all, if I mark this as the principal focus and this as the second focus, then any ray which approaches the lens such that it would have moved towards F1 would be rendered parallel to the principal axis. So therefore, the incident ray can be represented as, so if the lens was not there, this ray would have struck at F1. Now question number 2c, define EMF of a cell, state its SI unit. Now EMF of the cell is defined as the potential difference across the cell when no current is drawn from the coil. However, a more technical definition is, it is the work done in taking a unit positive charge completely round the circuit which is internal circuit plus the external circuit. And the SI unit of EMF is volts, and since it represents the amount of work done in taking a unit positive charge completely round the circuit, we can say it is joules per coulomb. So therefore, we can say 1 volt is equal to 1 joule per coulomb. Look at the next question. Name two electromagnetic waves, one of shorter wavelength and another of longer wavelength as compared to visible light. So we know very well that wavelength wise, gamma rays is the smallest wavelength, then comes X-rays, then comes UV rays, then visible, then infrared, microwave, and finally the radio waves, which have the longest wavelength. So the wavelength of gamma is the least, visible is moderate, and radio waves is very big. So therefore all these radiations have a shorter wavelength than visible, and all these have a bigger wavelength as compared to the visible light, or longer wavelength as compared to the visible light. Now have a look at this numerical. An electrical heater is marked 220 volts, 550 watts. What information does it convey? What is the resistance of this appliance? So as far as the information it conveys is that if the heater is connected to 220-volt power supply, then it will consume 550 joules of energy every second. And also this device, that is the heater, functions optimally only if connected to a 220-volt power supply. To calculate the resistance, we can use the formula P is equal to V square upon R. So R is equal to V square upon P. We have been given the voltage at which it is working, 220 volts, and the power is 550 watts. So this turns out to be 220 into 220 upon and 55 4s are 220. So therefore the answer is 88.